Hi, today we're starting Module 4, Lesson 1, the relationship of addition and subtraction. Now today's lesson might seem kind of silly and ridiculously simple. Don't let that scare you. It is really simple. However, it's building a foundation for further into the unit when we get to the expressions and equations, what this module is about. Okay, so basically we're using simpler numbers to understand a concept that we're going to build upon later. Okay, so don't overanalyze this, like, oh, it's so much more. It's really not. It's really that simple, okay? But still, even though I'm telling you it's simple, if you find it confusing, please make sure you ask questions. Okay, let's go back to good old tape diagram. So in your notes, draw a tape diagram to represent 5 plus 4. So let's show 5. Come on. 5 plus 4. 5 plus 4. Now remember that an expression does not have an equal sign. An equation does have an equal sign. So an expression doesn't have to have an equal sign. So there, that's just how we would represent 5 plus 4. What does each unit represent? 1. Right, exactly. So take a look at the second example. What expression, not an equation, what expression does that tape diagram represent? Exactly. And the next one, what expression does that represent?
3 plus 4.
Right. Okay? So now I just want you to put your pencils down and take a look for a minute. Okay, let's talk about it. If each of the squares represent 1 unit, let's represent the number 3. So 1, 2, 3. All right, does everybody agree that that's 3? So let's add 2 more squares. 1, 2. What expression could we write to represent that? Yeah. Like I said, don't be tricked that it's so simple. Okay, so we did 3 plus 2, but now let's remove those 2 squares. So we had 3 plus 2. What did we do next? How could I add that on to the, well, how can I include that into the expression? What did I do? So first I had 3, right? I had my 3. Then I added 2. But then I took away 2. So this whole expression represents the steps that we just did. So now evaluate means to solve. What's my answer? So what's my answer? What did I have left? I had 3. 1, 2, 3. I added 2. I took 2 away. And what did I have left? Everybody? 3. So if I add a number and take the same amount of let me try that again. If I add a number and take the same amount away, what am I left with? Not 0.
The same number you started with.
Exactly, the first number that we started with. See, I still have those original 3. Let's try another example, okay? And maybe it'll be a little clearer. All right, this time I'm going to start with 6 squares. So I have 6 blue squares there. Now, I added 4 more. So do you see the 6 plus 4? 6 blue plus the 4 red. So far, so good? Now it wants me to remove 4. So I had 6. I'm sorry. How many did I have? I had 6. I added 4. But then I took away 4. So how many tiles are left? 6. So if I evaluated it, what's my answer? 6. How many tiles did we start with? 6. So I had 6, added 4, took 4 away. So that left me with my original number. So like we just said, adding and then subtracting the same number of tiles results in the same number that we started with.
And you do 4 minus 4, which equals 0, and then add that to 6.
No, because that's not what we did. We never had 0 tiles. We had 6, we added 4 red ones, then we took away 4 red ones. They really should all be the same color because they all represent the same unit. I just made them different colors so that you could see what we were working with, okay? So, if I had a certain amount of tiles, okay, say 6, I have 6 tiles. If I add 215 and then take away 215, how many do I have? Everybody? 6. So what do we notice between that and notice about the examples that we did with the tape diagrams? Whenever we have a number, if we add and take away the same number, we're back to our original number. Exactly. So is this going to work no matter what the number is? So instead of using numbers, let's use our variables. Remember that a variable is a letter that represents a number. So that letter can change, but not in one equation. So like today, we could say that W is 6 and X is 4. And in that equation, W will always be 6 and X will always be 4. But in the next problem, or tomorrow, W could be 13 and X could be 47. But through that whole problem. So the value of those variables change in each problem. But it always stays the same in that one problem. Okay, does that make sense? So let's take a look. So we have this number sentence. W plus X minus X equals W. So let's see if we can prove that. So I have a W. Okay? Now what do I do to my W? I have my W, and they want me to add an X. So now I have a W with an X, but what do they want me to do? Take the X away. So what am I left with? W. Is that the same thing that I had when I started? Yes. So again, this number sentence is called, and here's your word, identity. This number sentence is called an identity because the variables can be replaced with any numbers and the sentence will always be true. So no matter what letter I use for W, no matter what letter I use for X, I will always get that W number back again. Okay? Let's go back to your notes. Predict what will happen when a tape diagram has a large number of squares, but some are removed, and then the same amount are added back. So now we're doing it the other way. Instead of adding and taking away, now we're going to take away and add. So write a prediction in your notes. What do you think is going to happen? We have a large number, we take away, and then we add. What do you think is going to happen? You're writing this down in your notes. So in your notes, write down what's going to happen. We saw what happened when we added and took away the same number. What do you think is going to happen when we take away and then add? You want to share your prediction?
You will get the same number you started with.
All right, let's see if that prediction is true, that we will get the same number that will keep its identity. For example, I'm Mrs. Lebowski. If I add 20 pounds and then take 20 pounds away, I'm still back to the same Mrs. Lebowski, right? It's my same identity. All right, so they want you to build a tape diagram with 10 squares. So go ahead, you could draw your 10 squares. So they want us to take 6 away. So how many am I left with? So I had 10, Ooh, that's wonky. Why did it do that? I had 10. Look at that. And I took 6 away. That was my first step. Now the next step, I had 10. I took 6 away, and they want me to... Oh, and it was there. They want us to add 6 back. So this is my expression. 10 minus 6 plus 6. I had 10, took 6 away, added 6 back. So evaluate means to solve. So what's my answer? What's 10 minus 6 plus 6? 10. Exactly. Okay? Now that we see what it means, let's try it. So 4. Okay. 4 plus 5 minus what will give me 4? 25 minus what plus 10 will give me the identity of 25 back. Very good. C, what plus 16 minus 16 will give me 45. Right. And 56 minus 20 plus 20. Right. Because as long as we're taking away and adding the same thing, we get our original number back. It doesn't matter if we add and then subtract, or if we subtract and then add. Either way, we get the original number back. Let's try it with variables. A plus B minus what will give me A? C minus D plus D will give me... If I'm going too fast, please raise your hands and ask me to explain it differently. Anybody have a question? Okay. C, E plus what minus F equals E? Everybody? What minus H plus H equals G? Everybody? G. That's right. So in closing, the final value of the expression equaled the initial because we took away and added, or added and took away the same value. Okay? So right now we're going to do a little bit of review. So I'm going to stop the recording and ask everybody to take out dry erase pen, an eraser, and a dry erase board.